Assalamu alaikum, my dear student. How are you? I hope all of you are fine by the grace of Almighty Allah in this pandemic situation. I am Golam Mortuja and I am your physics teacher from Mohammadpur branch. In this pandemic situation, all the teachers of physics department of Milestone School and College, we are doing our level best for you. That's why you can continue your study staying at your home. So, my dear student, in this pandemic situation, you are getting more time than before. So, please do not waste a single minute and utilize all of this time very carefully. Dear student, today I will discuss chapter 6, which is based on effect of heat on matter. In this chapter, today I will discuss two creative questions. This is my request to you. Please, my dear student, give your full attention in this class and learn these two creative questions. Hello, my dear student. This is our first creative question. So, look at the stem. The distance of two electrical poles is 50 meters. And in winter season, the temperature of air is 30 degrees Celsius. These two electrical poles are connected with a copper wire of 50.033 meter length. That means these two poles are connected with a copper wire of length 50.033 meter length. In winter season, the temperature is 5 degrees Celsius. The mass of copper wire is 30 kg and the specific heat of the copper wire is 400 joule per kg per Kelvin. Okay. Number A question is, what is freezing point? Do you know what is freezing point? Okay, let me clear it. At standard pressure, at which temperature ice starts to melt, that is freezing point. Normally, the freezing point for ice is 0 degrees Celsius temperature. Okay? I hope you understand what is freezing point. Dear student, B number question is, how do bats travel using the ultrasonic sound? Explain it. Dear student, do you know a bat is blind? But how do bats travel from one place to another place easily? Okay, let me explain it. While flying, a bat uses its throat to produce sound and spread it. If the sound returns to bat after reflection any obstacle, then a bat can ensure that there is an obstacle that is not the right path for bat to fly. If the sound doesn't return back, then at that time a bat can ensure that there is no obstacle and that is the right path for bat to fly. Okay? And for this reason, the bat can fly in the dark without being obstructed. Do you know why you cannot hear the sound which is produced by bat? Because usually a bat can produce the sound of frequency 100 kilohertz or more. That's why we cannot hear the sound which is produced by a bat, because we can hear only the sound of frequency which is between 20 Hz to 20 kilohertz. Okay, that's why we cannot hear. I hope you understand how do bats travel using the ultrasonic sound. Dear student, number C question is, how much heat is given up by the copper wire in winters? So let's start to solve this math. At first we have to write the given value. Okay, here you can see that at first the mass of copper wire is 30 kg. Okay, so 30 kg. The temperature during summer T1. T1 equals to 30 degrees Celsius. Dear student, we have to convert this degree Celsius to Kelvin. That means if we add 273 with 30 degree, then it will convert from degree Celsius to Kelvin. So add 273 to convert it from degree Celsius to Kelvin. Okay, and the temperature during winter. Here you can see that 5 degrees Celsius. 5 degrees Celsius. We have to convert this value from degree Celsius to Kelvin. So here if we add 273, then it will convert from degree Celsius to Kelvin, to 78 Kelvin. And the specific heat of copper is given S equals to 400 joule per kg per Kelvin. Here you can see that. And we have to find the rejected heat by the copper wire in winter season. Okay? Dear student, we know that the heat equals to ms del T. Del T means the difference of the temperature. Okay? So we can write ms T2 minus T1. So at the time we have to put m equals to 30 into s equals to 400, t equals to 278 and T1 equals to 303. Okay, and if we multiply all of this value, so the value will be minus 3 into 10 to the power 5 joule. So the rejected heat by the copper wire in winter season will be minus 3 into 10 to the power 5 joule. Do you know why the answer is negative? Because in winter season the heat will be rejected by the copper wire. That's why the answer is negative. Okay, so the amount of heat rejected by the copper wire is 3 into 10 to the power 5 joule. I hope you understand how to find the heat is given up by the copper wire in winter season. Dear student, the number question is, in winter, is there any possibility of tearing of the copper wire? Analyze mathematically. Okay, here you can see that the temperature of air is 30 degrees Celsius in summer and the temperature is 5 degrees Celsius in winter. That means if the temperature is decreased, then there is a possibility to tearing of the copper wire. But we have to find it. It will be tear or not. Okay. Here you can see that the temperature is decreased. So the copper wire also will be decreased. But if the copper wire is less than the pole distance, then it will be tear. If the copper wire is more than the pole distance, it will be not tear. Okay, so we have to find it. What will be the length of the copper wire in winter season? Okay, here you can see that the length of copper wire in summer season L1 equals to 50.033 meter. The temperature during the summer is 30 degrees Celsius. The temperature during winter T2 equals to 5 degrees Celsius. And we know that the coefficient of linear expansion of the copper wire is 16.7 into 10 to the power minus 6 per degree Celsius. And we have to find the length of copper wire in winter season. Okay, so my dear student, we know that the coefficient of linear expansion alpha equals to L2 minus L1 divided by L1 into T2 minus T1. So at the time we have to do the cross multiplication. L2 minus L1 equals to alpha L1 T2 minus T1. Then we have to change the side of L1. L1 plus alpha L1 T2 minus T1. At the time, if you put all of this value in this equation, then we will get the value of L2. So L1 equals to 50.033 plus alpha equals to 16.7 into 10 to the power minus 6 into L1 equals to 50.033 into T2 equals to 5 minus T1 equals to 30. If you put this value in your calculator, then you will get the value of L2 equals to 50.0121 meter. Okay, dear student. So, dear student, here you can see that the length of copper wire in winter is 50.0121, which is greater than the distance between two poles. That means in winter the wire will not break. Okay, because the length is greater than the distance between two poles. If the length of the wire is less than the distance between two poles, then it will break. Okay, but here the wire will not break. Dear student, I hope you understand how can we know that the copper wire will break or not in winter season by mathematically. Dear student, this is our second creative question. Here you can see that this is a metal piece. The length is 4000 millimeter and width is 3000 millimeter. And the surface area of the figure is increased by 0.1 meter square for rise of temperature 30 degrees Celsius. That is the stem. And here the number A question is, what is resolution? Dear student, do you know what is resolution? Okay, let me explain it. The process of turning a solid matter to liquid by giving the pressure and again turning it back to solid from the liquid by decreasing the pressure, and that process is called resolution. I hope you understand what is resolution. Dear student, number B question is, explain the plasma state of matter. Do you know what is plasma? Plasma is the fourth state of matter. The first state is gas, the second state is liquid, the third state is solid, and the fourth state of matter is plasma. Usually the plasma is gas ionized in extremely high temperature. A large source of plasma is sun. Aside from that, the other stars are also the source of plasma. The state of plasma occurs in thousands of degrees Celsius temperature. Like gas, plasma doesn't have any specific volume and specific shape. Plasma particles are electric conductors. That means through the plasma particle we can pass the electricity. The metallic matter is cut by the plasma torch in factories. That means some factories uses plasma torch to cut metallic matter in their factories. Dear student, C number question is, find out the coefficient of linear expansion of the metal piece. Here first we have to write the given value. Okay, so length of the metal piece, here you can see that the length of the metal piece equals to L 4000 millimeter. But we have to convert this millimeter value to meter. So if we convert millimeter to meter, we have to divide it by 1000. Okay, so it will be 4 meter. And here you can see that the width of the metal piece B equals to 3000 millimeter. We have to convert this value to meter. So if we divide 3000 by 1000, then it will convert from millimeter to meter, and the value will be 3 meter. Here you can see that the increased temperature is 30 degrees Celsius. So the increased temperature is 30 degrees Celsius, and the increased area del A equals to, here you can see that 0.1 meter square. So 0.1 meter square, and the initial area of the metal piece. If we multiply the length and the width, then we can get the initial area of the metal piece. Okay, so we have to multiply length with L equals to 4 meter and width equals to 3 meter. So answer will be 12 meter square. Okay, and we have to find the coefficient of linear expansion. Student, we cannot directly find the coefficient of linear expansion by using all of this given value, because here you can see that there are given initial area, increased area, and by using this two information we can find at first the coefficient of area expansion, but after that there is a relation between the coefficient of area expansion and the coefficient of linear expansion. So at first we have to find the coefficient of area expansion. Using this coefficient of area expansion, we have to find the coefficient of linear expansion. So student, we know that the coefficient of area expansion beta equals to del A divided by A1 into del T. So put all of this value in this equation. Del A equals to 0.1, A1 equals to 12, and del T equals to 30. So we will get the coefficient of area expansion equals to 2.77 into 10 to the power minus 4 per Kelvin. If the coefficient of linear expansion is alpha, we know the relation between the coefficient of linear expansion and the coefficient of area expansion. Okay, we know that the relation is beta equals to 2 alpha. So alpha equals to beta divided by 2. So put the value of beta 2.77 into 10 to the power minus 4 divided by 2. So we will get the coefficient of linear expansion alpha equals to 1.39 into 10 to the power minus 4 per Kelvin. Student, here you can see that the coefficient of linear expansion alpha equals to 1.39 into 10 to the power minus 4 per Kelvin of the metallic piece. I hope you can understand how can we find the coefficient of linear expansion by using the coefficient of area expansion. Dear student, our today's last question is, what will be the increase in temperature to increase the surface area of the metal by 6%? That means if we want to increase the piece of metal by 6 times than the before, then what will be the increased temperature? We have to find it. Okay, so here you can see that the given value, initial area of the metal piece from the C number question, 12 meter square, and the coefficient of the area expansion also we have got that value from number C question, 2.77 into 10 to the power minus 4 per Kelvin. Increased area according to the question, del A. What will be the value of the increased area? Increased area will be 6 times greater than the previous area. That means A1 into 6%, 12 meter square into 6 divided by 100 equals to 0.72 meter square. And we have to find the increased temperature. That means if we want to increase the area 0.72 meter square, what will be the increased temperature? We have to find that. Okay, You can see that the given value of the coefficient of area expansion and the increased area, and we have to find the increased temperature. So we have to use the coefficient of the area expansion formula. And we know that the coefficient of area expansion beta equals to del A divided by A1 into del T. We do the cross multiplication, then del T equals to del A divided by beta into A1. If we put all of the value in this equation, we will get 0.72 divided by 2.77 into 10 to the power minus 4, which is the value of the coefficient of area expansion, and we have to put the value of A1 12. Then we will get T equals to 216.6 degrees Celsius, and that is the answer. I hope you understand what will be the increase in temperature to increase the surface area of the metal by 6%. We have to increase the temperature 216.6 degrees Celsius if we want to increase the surface area of the metal piece by 6 times than before. Dear student, I hope you have enjoyed the class, and inshallah see you in the next class. And this is my request to you, please, in this pandemic situation, stay at your home and keep yourself safe. Assalamu alaikum everyone.